Moving on to test your understanding. 4 objects move during a 4-second interval of time according to the velocity versus time graph shown. Rank the objects in terms of acceleration and displacement during this time. Rule number 1 when looking at a graph is we need to look at our axes to see what the information is given to us as. So we have velocity and time for all 4 of these graphs. So that means we know the slope of a velocity versus time graph is acceleration, and we know that the area under the curve is our displacement. So first things first, we need to we can do our acceleration or we can do the displacement. I say acceleration because it should be easier, though to be honest with you, this is my second time recording this video because I messed up the first number. So, on to our slope. Rise over run. We can do rise up the whole thing, 20 divided by 4, or we can go up 10 divided by 2. Either way, we get an acceleration here for A of 5. And I'm going to write this down so that way I can first get my accelerations and then rank them. Acceleration for B is going to be flat line, 0, no rise, no acceleration. Notice I'm leaving off my units to conserve space. The next one, we're dropping down 5 over 2. So that means our velocity is getting closer to 0 and closer to the bigger negative numbers. So that means we have a negative 2.5 acceleration. For D, we're going up 10 and over 4, which is a positive 2.5 meters per second squared acceleration. So now we can look at our magnitudes. The biggest one is 5, so A. The next biggest one, so we'll just say, is greater than D, which is 2.5. The next biggest one is going to be B, because 0 is bigger than negative 2.5. And then finally C. For the displacements, we're going to just find the area under the curve. So we'll add up this area, and we'll add up this area. Remember that because we're down here in negative world, that means this is a negative displacement, and this is a positive displacement. We have to add these two up together to get our total displacement. So our displacement for A is going to be, if we just take these two triangles, we can just add them together and do length times width. Subtract our positives. Subtracting from the positives gives us a displacement of 0. Displacement A is 0. The positive equals the negative. Next one, we're doing length times width. So this junk here, our displacement for B is going to be 10 times 4, 40. I think. Next one, C. Again, we can do 1/2 base times height, or length times width divided by 2 to figure out these two. So our length is 2, our width is 5, so that's 10 plus a negative 10. Our displacement for C is going to be 0. Now on to the last one, our rise, or base times height, half of that. We're going up 10 and multiplied by 4, length times width. 10 times 4 is 40, half of that is 20. But we're in negative world here, so our displacement for D is negative 20 meters. Now we're just going to rank them. We can see that 40 is the biggest, B is going to be our greatest, which is greater than negative 20, 0, 0. A, which is equal to C, which is greater than D, because D is negative 20. Now for down here, use a position versus time graph here to answer the following questions. At what time does the object go the fastest forward? Fastest forward on a displacement versus time is going to be the most positive slope. So the most positive slope happens right here at 0 and then again at 4. So that can be 0 or 4. At what time does the object go fastest backwards? That's going to be the biggest negative slope, which happens at exactly 2 seconds. At what time does the object have zero velocity? That's going to be when the object changes direction, or when the slope is 0. So it's going to be a flat line here and a flat line here. So it can be either at 1 or 3. During what time interval does the object have a positive acceleration? Positive acceleration happens when our velocity is getting bigger or more positive. Not necessarily bigger, but more positive. And that happens between 2 and 4 because our velocity is getting bigger in the negative direction, and then our velocity is getting bigger in the positive direction. During what time interval does the object have negative acceleration? So that means we're getting more negative. So that's going to happen when our velocity starts slowing down here until it stops and then turns around and then turns around and then speeds up. So that's going to happen between 0 and 2 seconds. Last one, used the velocity versus time graph, last one on this page, to answer the following questions. When does the object go the fastest? Forward. Fastest forward is going to be, velocity versus time graph. All right, so it's going to be a little bit different. The fastest forward is when we have the greatest possible positive velocity. So that's going to be at 0 seconds. At what time does the object go fastest backward? That's going to be when we have the biggest velocity in the opposite direction. So that's at 2 seconds. At what time does the object have zero velocity? Well, that's when we hit 0, which is at 1 and 4. During what time interval does the object have positive acceleration? That's going to be between 2 and 4 because our velocity is moving towards more positive numbers. And then what time interval is the negative? That's when our velocity is moving more towards the negative numbers, or towards more negative numbers. So that's going to be between 0 and 2 seconds. There we go. That's it for this page.